or we've seen x equals some function of y. And so we can work out dy by dx over here, or we could have done dx by dy of this and worked out something and then said dy by dx equals 1 over whatever the thing is. So we can say f dash of y. Okay, so we're used to doing that when either y or the x is the subject of the equation. Okay, now what happens if it isn't? What happens if you get something, I don't know, something that is a bit dodgy? Let's just give you an example. When we have something that looks like this, x cubed plus x plus y cubed plus 3y equals 6, where it's difficult to make one letter the subject and differentiate, these are the instances where we use implicit differentiation, where we get a function of x and y. We get a function of x and y. So if ever you see a function of x and y where it's difficult to make one letter the subject, that's where we're going to use implicit differentiation. So I'm just going to give you a trivial example. Let's say we had x squared plus y, 3y equals 0. Now I know you can make y the subject here, but just to show you how you would go about differentiating this so that you can understand, when you differentiate x squared, what are you going to get? So we're going to differentiate everything with respect to x. When you differentiate x squared with respect to x, what do you get? Yeah, that's very good. We get 2x, right? So x squared becomes 2x. Now, when we differentiate 3y, what we're going to do is we're going to differentiate this as per usual. So when we differentiate 3y, we're going to get 3. But every time you differentiate a y term, we're going to just write dy by dx multiplied by whatever the differential is. And when we differentiate 0, we get 0. So then we get 3 dy by dx equals 2x, and dy by dx is going to equal 2x over 3. And that's now we've made dy by dx a subject here. So minus 2x, what am I even saying? Yeah. Okay. So I'm going to here work through this example just so you can see exactly how this works for a more complicated example. So let's have a look. So I've got e to the 2x ln y equals x plus y minus 2. Now looking at this, we can see that it's difficult to make x or y the subject here. It's going to be pretty much impossible, right? And so this is an instance where you would use implicit differentiation. So how do we do that? Now, firstly, we have to recognize all the techniques of differentiation we've learned before still apply here. So product rule is still going to apply here. So what I'm going to do first is say u equals e to the 2x and v equals ln y. Can you please tell me what is u dash going to become in this case? Type that in the chat, please, everyone. So we get 2e to the 2x. So that's good. Everyone's got that good. Right. When we do v dash, when we differentiate ln y normally, what would we get? When we differentiate ln y normally, what would we get? We would get 1 over y. But because we've differentiated a y term, we're going to write 1 over y dy by dx. That's the important bit. Okay, make a note of that. Every time we differentiate a y term, we are going to multiply a dy by dx next to it. So now if I use the product rule, v times by u dash, so 2e to the 2x ln y plus u times by v dash e to the 2x times by 1 over y dy by dx. That's the left-hand side differentiated. Is everyone happy with that? Any questions there? Is anyone unsure about anything I've done so far? If you do come across any questions, let me know if you're unsure about even a single term, just so that I can eliminate that misunderstanding. Now we look at the right-hand side. When we differentiate x, what do we get? We get 1. Yeah, that's nice and simple. When we differentiate y, what are we going to get? Because we're differentiating y, first we're going to differentiate y and we're going to put 1. But because it's a y term, we're going to put dy by dx. We're going to multiply dy by dx next to it. Or obviously you could have written dy by dx just by itself, because 1 times by dy by dx is just dy by dx. Okay. So y differentiated is 1, and we get 1 dy by dx. When you differentiate x, we got 1. When you differentiate minus 2, that becomes 0, so that disappears. We don't need to worry about that. Right, I want you to now make dy by dx the subject of this equation from here. And let me know what you get once you are done. So to make dy by dx a subject, I can collect dy by dx on one side. So maybe I'm going to collect them on the right-hand side and everything else on the left-hand side. So 2e to the 2x ln y minus 1 equals dy by dx minus e to the 2x 1 over y dy by dx. So what I can do now is I can factorize dy by dx and get 1 minus e to the 2x 1 over y, and the left hand side has stayed the same. And so to make dy by dx the subject, all I need to do is divide through by the bracket on the right hand side. Now you could have decided to collect dy by dx on the right hand side. All that's going to do is you multiply everything by minus 1 and you get the same answer. So you could equally have had dy by dx equals 1 minus 2e to the 2x ln y over e to the 2x 1 over y take away 1. So both answers are absolutely correct. Now the question is saying find the value of dy by dx at the point where the x coordinate is 1 and the y coordinate is 1. So I can now substitute x and y coordinates in there. So let's have a look. When I substitute x equals 1 in there and y equals 1, I get 1 minus 2e to the 2 ln 1 over e to the 2 times y 1 over 1 is 1 minus 1. But ln 1 is equal to 0. So in fact, this term cancels out, and we are left with 1 over e squared minus 1 as one answer. Or we could equally have got minus 1 over 1 minus e squared. Either answer is fine. That's the exact answer. And yeah, that's what they have here. So check that by typing that in the calculator. We can check this. And I can prove to you that both are the same thing. Right, okay. Let's continue with this for now. So, what do I have? 1 over e squared minus 1. We get 0.157. Or if I typed in minus 1 over 1 minus e squared, we get the same answer. So 0.16. Either way, we get the same answer, and you should be happy with that. Does that make sense? Is everyone happy with that working out? So here, what do we have? We've got x squared plus y cubed equals 2. When I differentiate x squared, what am I going to get? When I differentiate x squared, what do I get? 2x. So that's that term done. When I differentiate y cubed, what am I going to get? 3y squared. And because I've differentiated a y term, I'm going to multiply that by dy by dx. When I differentiate 2, what do I get? 0. So this is it now. Now all I need to do is make dy by dx the subject. So 3y squared dy by dx equals minus 2x, and dy by dx is equal to minus 2x all over 3y squared. And that's my answer. Okay, so if you made a mistake on that, can you please let me know what mistakes you made? So start off by writing this out. X squared plus 6x minus 8y plus 5y squared equals 13. Now, if I differentiate x squared, I get 2x, that's fine. Differentiate 6x, I get 6. Differentiate minus 8y, I'm going to get minus 8 dy by dx. Differentiate 5y squared, I get positive 10y dy by dx, and that equals 0 on the right hand side. Are you happy with that? Now I just need to make dy by dx the subject. I'm going to leave the 2x plus 6 on the left hand side, and I'm going to move 8 dy by dx plus 10y dy by dx onto the right hand side. It's not plus, it's minus now. So these are bits that you need to be careful of, the mistakes I'm making. So dy by dx, if I factorize that out, I get 8 minus 10y. I've got 2x plus 6 here. And if I now make dy by dx the subject, I get 2x plus 6 over 8 minus 10y. Now I don't need to do any simplification of this. And in fact, when I do that, I'm going to increase my chances of getting it wrong. The less you do, the better. Now, What I'm going to also say, an equivalent answer you might have had was if you move dy by dx is onto the left-hand side and everything else on the other. So you could also put minus 2x minus 6 over minus 8 plus 10y as well. So both are correct answers. Okay, any questions there? The first example from the textbook that we did, we identified a product. So when I write that, the area where students make mistakes in implicit differentiation itself, as you can see, is not that difficult. It's quite easy, really. The areas where you make mistakes are not recognizing products. Okay, so here there's a product of two separate terms. And that's what you need to be careful for. If you don't recognize them, then you are going to definitely make a mistake. Treat that as U and treat this as V and do it like that. Okay, does that make sense? So y cubed is fine. That's 3y squared dy by dx. Now for the middle term, I'm going to say u equals 3x squared and v equals y. So u dash is going to be equal to 6x. What is v dash going to become here? Not 1. 1 dy by dx. Okay, yeah, or dy by dx. Now I can use the product rule. So here I've got 3y squared dy by dx. And then if I use the product rule, v times by u dash. So y times by 6x is going to become 6xy. Plus u times by v dash, we get 3x squared. And then when we differentiate minus 4x, oops, I've done something wrong here. 3x squared times by that is dy by dx, yeah. And then I've got minus 4 equals 0. Okay, that has to be my working out for this question. And like I said, if you made a mistake, then you need to put asterisk here and recognize that you need to use the product rule. That is the most common mistake. People just forget about that. Now, if I make dy by dx a subject, I can factorize dy by dx. 3y squared plus 3x squared equals 4 minus 6xy. And so dy by dx equals 4 minus 6xy over 3y squared plus 3x squared. Is it 3y squared? Or which term am I looking at? 3 is what? 3y squared? Yeah, so 3y squared dy by dx, yeah. So I've just factorized dy by dx out of this term and this term here because both of them have dy by dx, so that should give me that. Yeah, is that okay? or multiply everything by -1 inside here and you get the same answer. Now, so this is where everything starts coming together. So when I differentiate x, that's going to be fine. I'm just going to start with u. So u equals x squared and v equals x squared minus y. So u dash is going to be 2x, v dash is going to be 2x minus dy by dx. And the quotient rule is vu dash, so x squared minus y times by 2x minus uv dash x squared times by 2x minus dy by dx all over v squared is x squared minus y squared. So that's the right hand side differentiated now. And that is, when I differentiate x on the left hand side, I get 1. Why is it 2y? Why is 2yx squared? Have I done something silly here? Let me just check something. So, oh, does it say 2y? Oops, what am I saying? Classic mistake, right. I've copied the question down wrong. Oh, how annoying. Right, okay. So u now is going to change. This is going to change. This is going to change. Let's see if I can salvage it. So this is saying 2y at the top. So 2y, so 2 dy by dx minus 2y here. So hopefully that should now be okay. Now, luckily all the dy by dx terms are in the numerator. And so that makes life a lot more easier, to be fair. So what I can do here is take this denominator here, multiply it by 1, and we get x squared minus y all squared equals 2x squared minus y dy by dx. And I'm going to just expand these two terms out so that I can separate out dy by dx terms from other terms. So minus 4xy plus 2y dy by dx. Is everyone happy with that? Now, I need to factorize out dy by dx terms and take the non-dy by dx terms over to the other side. So x squared minus y squared plus 4xy equals 2x squared minus y dy by dx plus 2y dy by dx. Now I can factorize out dy by dx terms. Let's see if I can copy this down. And the final step is to divide through by the right bracket here. So we get x squared minus y all squared plus 4xy all over 2x squared minus y plus 2y. Okay, is everyone happy with that? Actually, I'm going to leave it like this for the time being, just so that you can see working out clearly. Any questions there? When we differentiate a bracket, can you describe to me how we have to differentiate a bracket? How do we differentiate a bracket? That's got to be the key thing here. Multiply the power down. Take 1 away from the power and multiply by the differential of what's inside the bracket. So when I differentiate what's inside the bracket, I get 1 minus dy by dx. That was the key thing. This area here is where most of the mistakes are made. Okay, did you do that? Did you make that mistake or did you avoid it? And then the rest of it I think is fine. 1 plus dy by dx plus 0. So when you differentiate 5, you obviously get 0. Okay. Now, when I do 1 times by that whole thing, I get 4x minus y cubed. And when I multiply dy by dx, I'm going to get minus 4x minus y cubed dy by dx equals 1 plus dy by dx. Going to move over dy by dx to the right hand side. So we get 4x minus y cubed take away 1 equals dy by dx plus 4x minus y cubed dy by dx. And so now I can factorize it and divide it through, and we should get x minus y cubed minus 1 over 1 plus 4x minus y cubed. Let's just check that to be sure. Yeah. Okay, so here is your answer to dy by dx, and that red bit there, if you did make a mistake, please make a note to yourself. Multiply by differential of bracket. And the bracket only had 2 terms, there weren't complicated terms. That's what made this fairly easy. Right, okay, I still do want to do a couple more. I'm going to do H and I. Can you have a go at H and I, please? Right, hopefully you recognize that both sides need the product rule. And it looks a bit messy. So e to the xy equals x e to the y. Right, okay, so on the left-hand side, we have got a product of e to the x and y. That should not be too difficult. So u equals e to the x. Work. Yeah, u equals e to the x and v equals y. U dash equals e to the x and v dash equals 1 dy by dx. So that's okay. So the left-hand side is going to become vu dash y e to the x plus e to the x dy by dx. That's the left-hand side, that's sorted. I don't need to worry about that. Did you get that? So maybe you get a couple of marks for doing that. Please let me know. So now u equals, so if we now look at the right hand side, u equals x and v equals e to the y. U dash is 1. Can you please tell me what is the differential of e to the y? What is the differential of e to the y going to become? It's going to become, when we differentiate e to the y, it's going to remain as e to the y, and we get dy by dx. Okay, so hopefully you got that. Now, if I use the product rule there and continue my differentiation from this, v u dash e to the y plus x e to the y dy by dx. So hopefully this is what you get. Now we need to collect dy by dx terms on one side. I'm going to collect them on the right. Doesn't really matter. So everything else is going to go on the left. So I'm going to have x e to the y dy by dx minus e to the x dy by dx. Is that okay? Any questions there? And from there, we can factorize the right-hand side. And divide it through. Or we could have multiplied everything by -1 here. So we could have had e to the y minus y e to the x over e to the x minus x e to the y. Either answer is acceptable. So e to the y minus e to the xy over x. Can you check your answers here and let me know whether you got them right or wrong? Yeah, that's fine. Okay, and if you did make any mistakes, where were the mistakes that you made? What was the simplification bit there? Where did you miss out? Can you just let me know? As in collect it all on one side and divide it all? Because you want to be specific.